Testing, 1, 2, 3. Here we go. We are live from the Goo household in Dallas, and we're gonna get into it with another fun-filled, action-packed, flipped geometry classroom video. So here we go. Where are my notes at? Oh, here we are. Whoever made these notes happened to put a little blank sheet over here. So today, I don't know why this thing says Unit 7. Looks like there's a lot of issues with our notes today, guys. But anyways, we're doing the mid-segment theorem. So check this out. Let's see what we have to say about the mid-segment theorem. So a mid-segment of a triangle is a segment that connects the midpoint of two sides of a triangle. Every triangle has three, count them, 1, 2, 3 mid-segments. So let's take a look at our little diagram over here. I'm gonna go over what it says. So remember, a mid-segment of a triangle is a segment that connects the midpoint of two sides of a triangle. So on this triangle right here, we've got three midpoints. M, you see right here, M, that's the midpoint of AB. So then that means AM is congruent to MB. All right, P over here, that's the midpoint of BC, this side, and that means BP is congruent to PC. And then lastly, we got our third midpoint, that's N, and that means that AN, boom, 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 is congruent to NC. All right? Remember, when we got a midpoint, that means the two parts are congruent, and that's the definition of a midpoint. All right, so what are the three mid-segments? What are the three mid-segments of our triangle over here? If you look at it, we got one right here, boom, MP. All right, let's look at another. Where's another one? We got another one. I'm gonna do it in the orange. Bam, PN. And then our last one, I'm gonna do it in the green. Bam, MN. Those are the three mid-segments in this triangle. Notice how they connect a midpoint of one side of a triangle to a midpoint of another side of the triangle. So what segments are congruent by the definition of midpoint? Well, they're labeled on the picture, and I said them to you earlier. So that's going to be AM. Whoa, hold on. Hang on a second. AM is congruent to MB, or you can say BM, your choice. All right, next. BP is congruent to PC. And lastly, what's the last one? What's the last one, guys? AN is congruent to NC. If that's what you said, give yourself a big high five. There you go. You did it. So those are the congruent segments by the definition of the midpoint. You can see it's labeled with the little marks on each side of them. So let's go on to the next part of the notes. On to the mid-segment theorem. Now this is going to be a definition, guys, so make sure you remember this one just in case we got some proofs. All right, so the mid-segment theorem says that the segment connecting the two midpoints of two sides of a triangle is parallel to the third side and has a length that is half of the third side. So if you look at our diagram right here, DE is, what are we going to say about DE and AC right here? Look at the little arrow. What does the arrow mean again? What's the arrow mean? It means parallel. DE is parallel to AC. And you can kind of see it in the picture. Look, DE is connecting the midpoint of AB and the midpoint of BC, and it's going to be parallel to the third side as per the definition, which would be AC. All right, and now DE equals, what can I say about the length of DE compared to the length of AC? DE is going to be 1/2 of AC, or we can say that 2DE equals AC, right? Because if 1DE equals half of AC, and I'm trying to see AC, then 2DE is going to equal 1AC. All right, so let's do some practice problems. This is a pretty crazy theorem, you know? Like, why does it make sense? Maybe we'll learn about it later, but we're going to save that for later. So let's go into the practice problems. Scrolling it down. All righty. Okay, so look at this. In all of these three problems, DE is going to be a midsegment of triangle ABC. We're going to find the value of X using the rules from the midsegment theorem. So make sure you're looking above to see those rules. All right, number one, X. Look right here. Okay, so DE is going to be the midsegment. DE is parallel. And what's the length of DE compared to AB? It's going to be half. So if DE is half, then what's X? It's going to be 14. X equals 14. DE is 7, and it's going to be half of X. So X is going to be 14. 7 times 2, 14. Number 2, this one, check it out. Remember, this midsegment right here, DE is the midsegment. A midsegment connects two midpoints. That means that AD is congruent to DB, and AE is congruent to EC. So, if EC is 8, what is AE? It's also 8. X equals 8. There you go. And the last one over here. All right, check it out. DE is the midsegment of triangle ABC. Okay, so DE is going to be what in relation to AC? DE is half of AC. If AC is 34 and D is half of that, then what is X, the measurement of DE? It's going to be 14. There you go. Give yourself a little pat on the back. Listen to that hearty pat on the back, full of just muscularity. What? All right, let's go to the last one over here. Ow. Okay, scrolling it down. Use triangle GHJ, where D, E, and F are midpoints of the sides. Let's do some labeling just in case we'd have to do something. D is the midpoint, so GD is going to be congruent to DH. HE is going to be congruent to EJ. And GF is going to be congruent to FJ. All right, so I've labeled that. Let's continue. Let's look at number 4. If DE, where's that? DE is 4x plus 5. I'm going to do this problem in the orange, okay? So if DE equals 4x plus 5, 4x plus 5, and GJ, that's all this right here, equals 3x plus 25, find DE. Now, how am I going to do that? First, I got to solve for X. Now, what's the relationship between the length of DE and GJ? Well, by the midsegment theorem, DE is half of GJ, so I can say that 2 times 4x plus 5 equals 3x plus 25. So if I solve this out, I'm going to distribute, boom, that's going to be 8x plus 10 equals 3x plus 25. I'm going to subtract 3x from both sides. And then that's going to leave me with 5x plus 10 equals 25. Now I'm going to subtract 10 from each side. That's going to leave me with 5x equals 15. I'm going to divide by 5 to find x. And that means x equals 3. Now that's not the answer. They wanted me to find DE. And what is DE? DE is 4x plus 5. X is 3, so I'm going to plug that one in. So 4x plus 5 equals DE. And I'm going to plug in the 3, so 4 times 3 plus 5 equals DE. I'm looking for DE, remember? So that's 12 plus 5 equals DE. And 17 equals DE. There is my answer. All right, let's go on to number 5, the last question of the day. All right, so I'm going to do this one in the blue. Actually, I'll just erase this stuff for you. Here you go. Okay, if EF, so where's EF at? That's right here. Whoa. EF is 2x plus 7. Boom. And GH, where's GH? That's over here. GH is 5x minus 1. What is EF? So you guys, you're going to try this one on your own, and we're going to check it tomorrow with your teacher. All right, guys, so good luck on this one. See ya in the next one. Peace.